All right, let's talk about Redis. Today, we're diving into its incredible versatility. We're going to break down the 5 biggest problems this powerhouse tool solves, using insights that have been battle-tested in production at absolutely massive scales.
I mean, think about it. Why do so many of the top companies out there rely on this one specific tool when they need both speed and scale? That's the core question, right? And it's exactly what we're going to unpack today, looking at how Redis solves some really tough scalability challenges.
Okay, so first things first, what even is Redis? Well, at its heart, it's an in-memory data structure store. Now, you'll hear it talked about most often as a high-performance cache, and that's definitely its most common job. But the key phrase you really need to hang on to is in-memory.
And that in-memory part? That's the secret sauce. That's why it is just blazing fast. It's not reading from a slow disk, it's accessing data directly from RAM. But its real power, that comes from its support for all these different data structures. We're not just talking about simple key-value pairs here. Redis can handle strings, hashes, lists, sets, and a really powerful one we'll get to later called sorted sets.
All right, let's tackle the first big challenge, slow applications. We've all been there. Your app is running fine, but as more and more users pile on, your database just can't keep up, and the whole thing just grinds to a halt.
So what's the solution? Well, Redis acts as a high-speed cache that you place right between your application and your main database. You can think of it as a super-fast, short-term memory for your app. And this simple idea has a huge, huge impact. By storing and delivering that frequently accessed data straight from memory, Redis dramatically improves your response time. This also takes a massive load off your primary database, letting it breathe. And when you need to scale even bigger, you can distribute that cache across a whole cluster of servers using a technique called sharding.
Okay, on to our second challenge, managing shared user sessions. This is a classic problem. How do you keep a user logged in when their request could be hitting any one of your many application servers, none of which even know the others exist?
The solution is actually pretty elegant. You use Redis as a central session store. So when a user logs in, all their session information gets stored in Redis. The user gets a cookie with a session ID, and then it doesn't matter which server their next request hits. That server can just use the ID to instantly pull their session data right from Redis.
But hold on. If Redis is in memory, what happens if it restarts? You don't want to lose all your user sessions, right? Well, you have a couple of options for data safety. You could use persistence, which saves the data to disk, but honestly, trying to reload that in a live production environment can be way too slow. The preferred method is replication. This copies all your data to a backup instance, which can then take over almost instantly if the main one fails. Let's look at problem number 3, resource conflicts. Imagine 2 different processes trying to update the exact same piece of data at the exact same time. Who wins? This is called a race condition, and it can lead to corrupted data and all kinds of nasty bugs.
Redis solves this with a really neat concept called a distributed lock. And the key to making this work is a powerful atomic command called setNX. It's short for set if not exists, and it does exactly what it says. It lets a client set a key only if that key doesn't already exist.
And here's how that plays out. So client 1 comes along and runs setNX. It succeeds, grabs the lock, and gets to work on whatever it needs to do. Now, if client 2 shows up and tries to run setNX on the same key, it's going to fail because the key already exists. So client 2 has to wait. Once client 1 is all done, it just deletes the key, which releases the lock for the next process in line. Simple, but super effective.
Our fourth challenge is a big one, system overload. How do you protect your APIs and your services from getting completely overwhelmed by a flood of requests, maybe from a single user or a buggy script that's gone wild?
You implement what's called a rate limit. For example, you might decide a single user can only make, say, 100 requests every minute. But the question is, how do you track that efficiently for everyone?
Well, Redis makes this incredibly simple. Here's the recipe. You use the user's ID as a key. For every request they make, you use the incr command to add 1 to a counter for that key. Then you just check, is the count still within the limit? If yes, you process the request. If not, you reject it. And here's the magic bit. You just set that key to automatically expire after 1 minute. So the counter just resets itself for the next window. It's beautiful.
For our final use case, let's talk about something fun, building a real-time gaming leaderboard. You need to be able to instantly show the top players, rank by their scores, and keep it updated constantly. That sounds trippy?
Well, the fundamental data structure that makes this possible is that Redis sorted set I mentioned earlier. It's a collection of unique items, but here's the key. Each item has a score associated with it, and the entire set is always kept sorted by that score, automatically.
And this is exactly why developers love Redis for this kind of thing. Sorted sets make pulling the top players by score an absolutely lightning-fast operation. Adding new scores or updating existing ones is also incredibly efficient. It makes building a leaderboard a genuinely delightful feature to implement instead of a total performance nightmare.
So, from caching all the way to leaderboards, you can see that Redis is just incredibly versatile. As the source material puts it, when it comes to using Redis, our creativity is the limit. These 5 use cases, they're really just the beginning.
Which, of course, brings us to the final question. After seeing how Redis can tackle these common, sometimes really complex problems with such elegant solutions, what problem will you solve next?